Before we begin, this project uses the UCI Wine Dataset, which is mostly used in academic and machine learning communities. It also sets a benchmark to test the YAML models which are created. And now this video does not promote or endorse alcohol or wine use. The focus is purely educational. Now let's get into the video. Hello everyone, welcome back. Now, from the disclaimer, you have guessed what I'm going to explain about. Well, we are going to explain about the wine classification, which is done using the machine learning model. Now you might guess, why wine classification? Well, this is a common data set, and now this data set, which is currently in UCI machine learning repository, garners over 131 citations. So this data set holds 178 real world records about the grapes, the three types of grapes which grow on the same soil, same land in Italy, but they are on three types mentioned as class 0, class 1, class 2 in a data set. Now this data set was initially created for chemistry to analyze the compositions of each component in those grapes, but now later it was used in YAML and other practices. And yes, this is a real world data and also uses chemical features. A group of scientists worked on the chemical features, then it came later for machine learning practices. So you want to know the data set? Well, as I said, 178 records of each chemical details about how the grape looks like, and also this is the image of the data set, which shows 5 rows, first 5 rows, and we are using the UCI Wine Dataset where class 0, which is Barolo grape, class 1 describes Grignolino grape, and class 2 is Barbera grape. This dataset was actually created in 1991. Others might consider this as a toy dataset, but what I have done is I haven't stopped for creating just a notebook, but what I have done is, as you can see in this graph, it shows the predictions of individual models, 3 models. Yes, I'm using a voting ensemble. So these are the ML stacks. I am using Logistic Regression, Random Forest and Support Vector Machine, which combine using a voting classifier, which is a soft voting. And now this voting classifier is deployed using JobLib, which is correctly used in a Streamlit app. There are so many interesting things behind it, and now this is how the app looks like. Whatever data you enter, it's going to give a real-time predictions, and before giving a prediction, it is checked with 3 models. Yes, model confidence, and also it has a comparison charts as you saw in a previous slide. Now, what's next? Well, I don't stop with just the Streamlit app, a comparison charts and also the predictions and also the user inputs alone. I'm going further with a deployment on render or using fast API and also using Sharp for explainability, because most of the models need a explainability of why this particular model derived in this particular conclusion. So this won't be a black box. you are going to see why this model derived in this conclusion clearly. But it depends on you. Yes, we are going to cross validate, and we are going to have some feature importance and also sharp values. And yes, as I said, there could be a fast API version. Can't kidding though. Now, if you are interested, if you are the one who's enthusiastic in YAML and data science projects, those simple datasets which are turned into a full stack YAML app, if you want to explore more on this, then I suggest you join this journey and subscribe to my channel for more insights. So this is how the tutorial structure looks like. The first part is done, and the second part is I'm going to create a YAML notebook with how the job loop works here, and then I'm going to build a UI for this YAML app. Then for part 4, as I said, if you are interested, we can go further with sharp values, or we can use fast API, or we can deploy this further in a backend. It all depends on you.